The world has come around to see we need to produce energy as responsibly as possible. However, there is one major hurdle that we face when it comes to producing energy through renewable sources: intermittency. Can renewable energy be produced anytime energy is needed? That is a question wind and solar power cannot answer yes to. There is, however, a breakthrough method of generating energy that neatly solves the intermittency problem that plagues wind and solar energy. This game-changing tech is tidal energy and is getting many players in the energy industry excited. What is tidal energy? How does it work? And what are the potentials? Join us in this video as we dive into tidal energy, which is 10 times better than wind and solar. Wind and solar energy are great ways to generate energy. They are relatively cheap and do not cause pollution, unlike fossil fuel-based generating stations that produce carbon emissions. Moreover, we can't run out of solar or wind power, at least not in a billion years. However, as great as wind and solar energy is, they have a serious drawback. They can be affected by environmental, seasonal, and daily cycles that can limit their use or efficiency. As such, renewable energy cannot always consistently produce energy at all hours of the day. For example, you can't produce solar energy when the sun has set. This is called intermittency. Intermittency is a big headache for energy professionals. For example, solar and wind farms' energy production in Europe has been known to vary between 0 to 23 and 24 gigawatts of energy respectively during peak times. Sure, these peak production periods provide a large share of energy. However, sometimes unpredictable lows are the bane of renewables. Compare this intermittency with the constant power output that can be generated by fossil fuel-based power plants using coal or natural gas, and you will see renewable energy's Achilles heel. Energy production companies try to mitigate this inherent flaw with battery solutions, but this only introduces a different set of problems, as you shall soon see. This is where tidal energy comes in. It is renewable energy, meaning no damage to the environment, and at the same time, it can be available all day and at any time, solving the intermittency problem of wind and solar energy. But what is tidal energy and how does it work? Simply, tidal energy is produced by the surge of ocean waters during the rise and fall of tides. When the water has risen to its highest level, covering much of the shore, it's at high tide. When the water falls to its lowest level, it's at low tide. Some lakes and rivers can also have tides. Here you can thank the sun and the moon because the two celestial bodies are responsible for the rise and fall of tides. How? The forces that cause tides are known as tidal constituents. For example, the Earth's rotation is a tidal constituent, but the major tidal constituent is the moon's gravitational force acting on the Earth. The closer objects are, the greater the gravitational forces between them, and this is why the moon exerts more pull on the Earth than the sun does, despite being significantly smaller. So basically, the moon is constantly pulling on the Earth, including on land surfaces. However, land surfaces do not move that much because they are not very flexible. They move not more than 55 centimeters a day. But when it comes to the ocean, the pull is more dramatic because water is liquid and can respond to gravity more. The moon pulls on both the side of the Earth facing it and the opposite side, but the greatest force is felt on the side closest to the moon. At the center of the Earth, the gravitational force is zero. High and low tides come with a degree of accuracy as the Earth continues to spin, and tidal energy engineers simply take advantage of this phenomenon. But how do they do this, or how does tidal energy work? The main trick is to harness the kinetic energy created from the rise and fall of ocean tides and currents, or tidal flows, and turn it into electricity. The larger the tidal range, or the height difference between sea level at high and low tide, the more power can be produced. When you want to build a tidal project, there are three types that you can choose from. The first is the tidal turbine, which is fairly straightforward. It is very similar to wind turbines, except that you place them below the water's surface instead of above or on land. So the water's current pushes the blade to the turbine, which is connected to a generator, and bam, you have produced electricity. Tidal turbines can produce much more electricity than wind power plants, and this is because water is much denser than air, meaning it will move the blades faster. However, the same water's high density also means that tidal turbines need to be much stronger than wind turbines, making them more expensive to manufacture. Tidal turbines are large, but they have the advantage of causing relatively little disruption to the ecosystem around them. They could cause collision damage like wind turbines, however, with marine life, but the slow speeds of the blades mean it isn't that much of a concern. The second type of tidal power project is the tidal barrage. Here, the tidal barrages are actually low-walled dams that are constructed at tidal inlets or estuaries. They are similar to your standard hydroelectric dams because you use sluice gates to form a reservoir on one side of the barrage. The barrage is attached to the sea floor, with the top of the barrage just slightly above where the water level hits during the highest tide. You then place your tidal turbines towards the bottom of the barrage inside a tunnel, which lets water pass through. The turbines are turned with the incoming and outgoing tides. During an incoming high tide, water flows over the turbines as the water rises. Then the water flows back through the turbines as it becomes a low tide. The turbines are connected to a generator which generates electricity. While tidal barrages are the most efficient way to harvest tidal energy, they're also the most costly. Engineers have to construct an entire concrete structure, which of course adds to the development costs. Also, the barrages have a more serious environmental impact on the surrounding ecosystem than tidal fences or turbines. You are basically building an underwater wall so fish and other sea creatures can't pass through, causing a myriad of effects on the local ecosystem. The last type of tidal energy project is the tidal fence, which is like a cross between tidal barrages and tidal turbines. Here, the vertical tidal fence turnstiles are positioned together in what looks like a fence, which is why it's called a tidal fence. Instead of spinning like a propeller, tidal fences spin like a turnstile. You produce electricity by using the energy from tidal currents to spin the turnstile blades, which are connected to a generator. Tidal fences have vertical blades that are pushed by moving water. These vertical turbines are installed together like a fence, but they don't require the large concrete structure that tidal barrages do. Usually they'll be installed in between land masses in things like inlets and fast-moving streams. They are submerged entirely underwater and have little impact on the surrounding ecosystem. So how do engineers decide if a site is suitable for locating a tidal energy project? The fact is that even though water covers 2/3 of the Earth's surface, not all the nations or regions on the Earth are suitable for tidal power projects due to the specific requirements. For example, the difference between flood tide and ebb tide must be minimally of the order of 4.6 meters